Hey everyone, Mr. Froelich here. I just wanted to take a quick minute and go through something called a station model and how to decode them. Now, a station model is something that a meteorologist will use to gather and show weather data in a very visual format. Weather data is collected at stations similar to this, and at a location like this, we will collect weather data like wind speed, temperature, dew point, precipitation type, and tons of other pieces of information that we can then compile into maps made by computers similar to this one. Now this looks extremely dense and populated in terms of the data shown, and to the human eye is not really that useful since we can't really tell which station model is which. But to a computer, it is very helpful in making more smoothed out and neat looking maps similar to the ones that the Weather Channel or other meteorologists put out. These maps are then used to help show the bigger picture items and present that information to the public that doesn't necessarily have all of the background knowledge that we've been learning in this unit. So to decode one of these station models, we're going to be looking at the symbols that go in it. A station model in a simplified format looks like this. And in a little bit, this is going to end up being a relatively easy thing for most of you to decode very, very quickly. So what I want to do is quickly go through some of the basic symbols that go into a station model. Now, make sure that you are following along on the half sheet for your notes so that you have all of this information in a quick, handy format. First, we will start with temperature. The temperature number is always the number that is listed in the top left corner of the station model diagram. Next, we will have dew point. Dew point is simply a measure of moisture in the air and in a way can be similar to humidity. Although dew point is more useful and we can go through why at a later date, that number will always be found in the bottom left section of the station model diagram. Next, we have the current weather. There may be a symbol that's shown in between the temperature and the dew point numbers, and that's going to represent whatever current weather is going on. There are several different symbols that I'm going to show you in a little bit. If there is nothing shown, then there would be no current weather happening at that moment. Next, we have sea level pressure, which is a compiled or compressed version of the millibar number that we've been using for pressure centers. Remember, 1013 is sort of the middle mark. Now, the way that it is plotted on a station model is not always convenient for decoding that, and doing so requires a little bit of a trick and some mental math in your head. We will go through that in a little bit. The last thing is sky cover, which is the circle that is shown in the middle, and it is the center of the station model. Decoding how cloudy it is very easy for students to do, and we will again have more information on that in a little bit. Coming here, we will see how we decode wind. Now, there are a few different ways that we can decode wind. The first one is to look at the line and the direction that it is going. Now, you have to remember that we always describe winds from where they are coming from. So in the example that I have drawn here with the black arrow, similar to the one on your half sheet of notes, this would be a northeast wind because it is coming a little bit from the north and a little bit from the east. You have to remember that we describe winds from where they come from, and the circle of the station model can kind of be thought as an arrowhead showing you the direction that that wind is pointing. The next part is actually measuring how fast the wind is going. For every long line that is drawn, that is worth about 10 miles per hour. For every short line, that is 5 miles per hour. And similar to the picture that is shown at the very top, what you do is you simply add them up. So again, the one that is drawn with the red or with a black arrow would be 10 plus 10 plus 5 for a total of 25 knots or miles per hour to simplify. You will also notice two other symbols. One of them has only one short line, and it seems to be indented from the bottom of the wind barb. What that represents is a wind that is going 5 miles per hour. And if you have one line that is shorter, indented from the bottom or from the end of that line, that is worth 5. If there are no winds at that time, you will see a second circle drawn around the middle circle, and that stands for calm winds. Moving on, these are the symbols that I'm going to ask that you know for decoding station models. Some of them are very straightforward and easy to remember, and a couple other of them will be a little bit more difficult to recognize or decipher from their counterparts. Now remember, there are over 100 different symbols out there. These are the more common ones that show up. The first one is going to be rain. Now if you have 1 or 2 dots, it would be light rain. If there are 3 dots, it is moderate, and 4 dots would represent heavy rain. Similarly, you have snow drawn with little stars. 1 or 2 stars is light snow. Moderate snow would be 3 stars, and 4 stars would be heavy snow. Next we have thunder. The little R symbol stands for thunder. If there's a dot on top of the R, it's thunder with rain. If there's a snow on top, then it would be thunder with snow. And if it's just the R by itself, that means there's thunder in the vicinity, but it is not raining or snowing at that station. Next we have showers, which are more of the off and on light versions of rain and or snow. So it's the triangle with either a dot for showers with rain or a triangle with the star for snow showers. Next we have the 2 commas for drizzle. We will have freezing rain or freezing drizzle will be sort of a squiggly line with a dot for freezing rain or a squiggly line with a comma for freezing drizzle. Next we have the triangle with a dot inside. This stands for sleet or ice pellets falling. And the last one is fog. 2 lines would be thinner fog, 3 lines would be thicker fog. So each of these symbols represents a current weather that is happening in that location. This can be very useful for meteorologists when they're trying to figure out what's happening and where certain weather conditions could be going in the future. And as mentioned earlier, if there is no symbol drawn, then there is no current weather happening. And what that means is that it just may be cloudy or sunny or something like that. There's no technical precipitation falling from the sky. Next we will have cloud cover. Cloud cover is relatively easy to figure out. Basically, you are trying to determine how cloudy it is and represent that by rounding it to one of the nearest quarters of this circle being filled in. So a clear day would have none of the circle or 0% of the circle filled in. A few clouds, which would be around 10% sky cover. Next, you will have scattered clouds, which would be about 25% cloud cover. You'll have partly cloudy, 50% cloud cover. Mostly cloudy, about 75% cloud cover. And lastly, you'll have overcast or 100% cloud cover. You can use the percentages to aid you in doing this, since understanding sometimes partly cloudy or scattered clouds can get confusing when we're trying to learn this, so the percentages is probably the easiest way to go. Saving the hardest for last, we're going to talk about plotting our pressure. Now, the pressure number is again shown in the top right corner of a station model, and one of the things that we do to shorten this number for the computers is we will either drop the leading 9 or the leading 10 and the decimal place. So here are a few examples coded that are on your half sheet. One thing to note is that if a 410 was coded as the pressure number, what that represents is a 1041.0. And here's how we get this. We look at where the decimal place is, and it's always going to go at the end. So the last digit always has the decimal place before it. And then you have to look at what number is in the front. Since a 4 is in front, then we're going to place a 10 in front of that 4, meaning that it is 1041. So in other words, if that leading number that is plotted is less than 5, then we're going to put a 10 in front to make that somewhere in the 1000 millibar or greater. If that leading number that is plotted on the station model is greater than 5, then what we're going to do is place a 9 in front, placing it somewhere in the 900s for that millibar. So the second example, again, is plotted as a 103. Since the leading number is a 1 and that is less than 5, we just place a 10 in front, so it becomes 1010, and the last number always gets the decimal, so it's 0.3. Looking at the third example down, having a 987 plotted, meaning that that leading number, the 9, is more than 5, we're going to place another 9 in front, which makes it 998, and the 7 is the last digit, so it gets the decimal place, 998.7. This one always takes a little bit of practice for students, and if you don't get it right away, don't worry, it takes time to figure this one out. So let's practice decoding a station model together. So you might be presented with a station model similar to this, and what you'll have to do is figure out what all of the weather data is on this station and be able to break it down. The more you do this, the faster and easier it becomes. And again, if you struggle with it right away, don't worry, it takes time to learn it, and we're going to practice this a whole bunch this week. So starting at the very beginning, we have a temp of 26 degrees. That is the number in the top left corner. Our dew point is 16 degrees, our number in the bottom left corner. We're going to look at a west wind because our wind barb is pointed to the west. That means our winds are coming from the west. We have two long lines, which means our total wind speed is 20. We're going to take 10 plus 10 to get that 20. Our pressure number plotted is 997. Since that leading number is greater than 5, we're going to add a second 9 in front, and the decimal place goes before the 7, so 999.7. Our current weather at the moment is moderate snow or light snow, and our cloud cover is 100% overcast. So again, use this as a reference for decoding station models. This should be all of the information that you need to plot and be able to draw station models on your own, given the information, and figure out what weather is happening in certain locations. If you have questions, feel free to message me on Schoology, and I will do my best to help you out. Thanks for watching.